Okay, so we just power on our Kubernetes cluster. Last time we migrated uh, our CNI from VNet to Calico. So you can see all these Calico uh, virtual switches are up and running uh, on all worker nodes and master node. kubectl get nodes. So these are all the virtual switches provided by the Calico are up on each worker node. And this is a controller, and these pods we last time spin up to just take a look at what IPs will be allocated. So now you can see each pod is running on a different worker node. This is on worker 1, worker 3, worker 2. And you can also see that we gave this Calico a big IP pool, 11.0.0/16. So further segregation of pool is allocated, and from that range, it is allocated to each worker node. So a master node also gain a range. So far, I cannot, there is not a single pod running on the master. By default, your load will not go on the master node. There is some restriction on the master node that will prevent the application to run on the master node. All the load by default will go to the worker nodes. So that thing is known as taint. So in further classes, we will see that what is taint. But right now, all my application pods are running, and good thing is each one is running in different worker node. So now if I quickly go to each worker node and show you the IP route. Last time there was VNet still pending, so I rebooted. After reboot, you can see there are three static routes on each node. So this network is reachable. /26 IP pool is decided by Calico. To reach this network, you can reach to this IP. To reach this network, use this gateway. To reach this network, use this gateway. And each node is connected by the VPN tunnel. Not the VPN tunnel, but the tunneling layer 2 tunneling protocol. Sorry, IP route. And here you can see, here you can see three static routes. Okay, and all are pointing to the device tunnel 0. And tunneling device is also got an IP from the same subnet. Okay, so let me just quickly do the this kubectl get pod hyphen and dev namespace we created. And I will do hyphen wide. All pods I created in this node, and I will do kubectl execute it this pod hyphen and dev. Now I am inside this pod, and from this pod, if I ping, I believe ping I installed in my last session. The update. Just a minute. I think without wasting this time, I think I install the ping on some different part. App 2. App 3, I remember has, yes, app 3 has two containers. By default, if you are not defining the contain, you can see when I connect with this pod, so it gave me message that this pod contains two applications, two containers. One container is app1 and one is Tomcat. So by default, first container will be connected if you have not defined. So it is connected with the app1 container. I think ping is not here. And if I connect with the -c Tomcat, actually ping will, yes, ping, I think. No, ping is not there. I think actually after the reboot, when the pod will container will go down, everything install will be lost because the storage in the container, is ephemeral. It's not permanent. So when I reboot the cluster, all pod lost whatever we wrote in the file system. Everything will be back from the file system defined in the image of the container. So apt update, just let me just do quickly this one. So this is reachable. Last time it was not working. And the other network. So all the networks are reachable by the Calico CNI. Okay, so we are done with this one. Now we have to start the topic that how this controller manager, what is the benefit of controller manager? So far you saw that whenever I create a container, I create these three containers. For example, I'm going to delete this container. Not container, the pod. So it is deleted. So what is the who will recover this? Basically, this can be failure due to the application failure or due to the human error. The pod can be done. So for this reason, we must have to run the pod under the controller provisioning. So by default, when you are starting the pod, it straightforward with the command line, or you wrote the manifest. Last time we wrote the manifest for this. We wrote the manifest for this pod to and we used kubectl apply to run this Nginx container inside the pod. So this will not guarantee the auto healing. So for that reason, we must have to run that pod under the controller. So to run the pod under the controller, we must have to use the controller manager, managed pod. So there is a concept of deployment. Or instead of deployment, first of all, I will show you the replica set quickly. So what is replica set? If you go to this Kubernetes documentation, you can see replica set purpose is to maintain a stable set of replica pod running on any given time, such as the often and guarantee the availability of the specific number of identical pods. Simple definition. When you requested to cluster that I need this number of pod against these images, so replica set will make sure this all the pods are up and running. If those pods are deleted due to some human error or due to system error, it will be recovered. So replica is defined with field. So now replica set is actually a resource of the Kubernetes cluster. We understand that kubectl API resources, these all resources we have. So far, what resource we created? We create the pod. We look into the nodes. We look into the namespaces. So now today we are going to look into the replica set. You can see, and then deployment, and then DaemonSet, and then stateful set. So this is the full name of these resources, and this is the short name. Whenever you will query, you can also use this short name, and you can see app/v1 is the API variant. So in the manifest, we will use this variant, and these resources are coming under the true mean. This is coming under the namespace. It is not a cluster-wide resource. Okay. So to create kubectl, create the replica set, first of all, I will show you the documentation that, yeah, this is the uh, uh, manifest of an application that is running under the replica set. All the pods will run under the replica set. This is the manifest. You can also write your own manifest. I think kubectl create, if I should do -help. So I should be able to see. I can create, actually all the resources I cannot manage by the command line. Just like you can see, I have a lot of resources under the API resources list. But here, kubectl create, I can only create cluster role, cron job, namespace. I can create a service, uh, deployment. It's been replica set I cannot create by command line. So for this reason, what I will do, I will straightforward copy this manifest, and I will create here a file. I don't think so. VIM will work here. File. Let me check this. No, actually, what is the problem? Or I think I need to use VI. No, this is actually, let me do this on the Linux machine. Okay, so I just copied this manifest. Its kind is replica set. Its API very we can see from the API resources list, and its metadata is its name is defined. This is a front end application, and labels. These two labels are assigned. How whatever label you want to assign, it depends. And under the specs, we can define how many replicas, mean how many pods we need under this application. So it's defined here three. And match label, uh, match label actually, it's selector. So selector basically is used when you are making a reference from one uh, Kubernetes resource with other Kubernetes resource. When we will correlate, so we will correlate with the selector. So there are different resources deployed on the cluster, and each resource has a selector and label. So we will perform different action on the behalf of with reference to label and selector. So right now they gave the a selector name tier front end. This is a front end application. And this is the template section, metadata, and then the labels. So this is the whole syntax of the manifest. You don't need to remember this. You can copy from anywhere. There is a special plugin in your Visual Studio that can help you to design this whole manifest file. And under the specs is same like what specs we use in the pod replica set, pod manifest. So what containers I want to run? I am running PHP radius container, and this is the image. So just to save the time, I will change here because my Nginx image is already downloaded on all worker nodes. So I will use the Nginx image quickly because otherwise it will try to pull down this image. And it's you can say the name of the container will be PHP app, for example. Okay, PHP app hyphen FE front end. So let me apply this. CTL apply. So under which namespace this replica set is created, it's under the default namespace. If I query kubectl get all mean all resources, mean all the pods and services and whatever we will create under this namespace. So hyphen n default. We don't need to define this default. So you can see there are three pods running, and there is one service. Let's forget about this one. We will discuss this. So if I query kubectl replica set in the default namespace, I can see the front end replica set is created. Its desired state is 3, and currently 3 pods are running and all are in ready state. And if I do a query to pods, I can see 3 pods are up and running. Names are randomly assigned, starting with the name of the replica set, and some random ID is assigned. And hyphen O wide, I can see all are running. Means scheduler distribute this law, this request of creation of these pods replica set, pods running under the replica set on different worker nodes, and they got their IP from their relevant virtual switches. So now all are in the running state. So for example, I delete a pod from, I delete this pod. So you can see this X7SJW is no more there. a new pod is created to fulfill the requirement of replica set. So replica set we requested 3. So this was the responsibility of the controller manager to guarantee the 3 running pods. So as I delete this pod, so controller manager requested API to create another one because right the demanded one were 3 and running were only 2. So now you can see this auto healing mechanism recreate this pod 37 seconds ago. And the IP you can see the last time was 5197, now 198. Okay, so this is the benefit of using replica set to make sure the auto healing. Whenever any disaster will happen, it will auto heal your application. So all the pods are using the same uh, image, kubectl. You do the describe this pod. You can see it in this description. Uh, it's in running state and its image is Nginx. Okay, and so whatever pod you will describe, you can see all the pods are having the same description. Image is used by all the pods. It is also using the Nginx image. So with this way, you launch 3 pods, and all pods are serving the same application. And you can, and now this is a separate question that how we will do the load balancing among these pods. We will see this when we will create the services. But right now, we just want to understand the benefit of replica set. So to use this, by using this replica set manifest, I create this application with 3 pods. And if I want to scale up the pods, I can do. So how can I scale up here? You can see some example here. So this is the complete definition. What is the, how you will write the manifest and what are the portion of that manifest files? I mean, API variant, kind, metadata. So what you have to write under these sections. You're working with replica set, deleting just a replica. We will delete the replica. Simple, I delete the pod, or we can delete the replica set. Scaling a replica set. If we want to increase the number of pods running under this replica set. So what I will use, there will be a command given, I think. This is talking about the autoscaler. So autoscaling is a different topic, but I want to show you. For example, if I change this replica set, same manifest, and change its value from 3 to, for example, 7. Okay, and now I again do kubectl apply -f. So actually, is in some documentation you will also see kubectl create. So kubectl create is different than kubectl apply. With the create and apply from scratch, if you are going to deploy some manifest, it will work same. But when you want to patch some manifest, just like I modify the replicas number of pod values. So in that case, I want to patch this replica set now. In the running state, I want to update the configuration. So what I will do, I will not use create, I will use apply. So apply is basically used for the modification, you can say, in the running. So it is now configured. And if I see kubectl get rs, the short form of the replica set, 7 out of 7 are up. Only 6 are ready, and 7th, I believe, is in process. If I do a kubectl get pods, so you can see the 7th one is in creation state. So now it expand the running pods on the fly. So it is still trying to spin up this pod. So let me just kubectl get pod hyphen -dev kubectl delete these pods. Now all 7 are up and running. And the scheduler divide the load of these pods across the cluster. Similarly, I can do the scale down. For example, I do app replica set. I am changing the replica value to 7 to 4. And I apply this. You can see 3 are in terminating state. Only 4 left. So this is the benefit. First benefit is auto healing. The second thing is scaling. If your more load is coming to your application, you can scale up the number of pods. When the load will decrease, you can scale down. So this, yes, yes.
This manual scale in and scale out what you are saying to reduce the pods and to increase the pods, isn't it possible that it do this automatically? I mean, if the
Yes,
application
yeah,
hires and
in practical life, it will be automatic. Actually, we need to deploy a metric server. If I type here top pods, this is also a Kubernetes command. So this command will show you what pod is using how much CPU and RAM. So right now, this functionality is not enabled in my Kubernetes cluster. I need to enable this functionality. Uh, then after enabling this functionality, I can enable the auto scaling. The documentation that I showed you here, it is saying that here you can see a replica set as a horizontal pod autoscaler. So in that case, we will set up the Kubernetes resource HPA, horizontal pod autoscaler. If I type here kubectl API resource, so API resources, I think. Yeah. So HPA, horizontal pod autoscaler, is another resource we will configure. We will attach this autoscaler with this replica set, and on load, when the load will come, it will automatically scale up your applications. Okay, so now I did everything manually and I apply by the manifest, but it's not possible that you will save this manifest lifetime with you, because maybe someone wrote this manifest and everything is lost, but the resource is deployed inside the cluster. So if you want to reproduce this manifest, whatever resources deploy in the Kubernetes cluster, and you want to reproduce, so actually what happened, everything of this manifest is saved in your etcd database. So to reproduce this, I can use kubectl, get replica set. First of all, I will see what resource is there. Okay, so I can use get replica set, the name of the replica set, and the namespace -o YAML. -o YAML will produce the output of this replica set in YML format. So it fetch everything from the etcd database. Whatever I defined in my manifest was the bare minimum configuration, but a lot of things are by default. So those values are default values are saved in your etcd database by a Cube API. Just like you can see the DNS policy I have not defined, restart policy I have not defined, scalar name, the default scalar. So in Kubernetes, we saw that there is a scheduler that is defining responsible to decide where your load will go. So you may are using in your Kubernetes cluster custom scaler. In that case, you will define your own scaler. Okay, so these are all the values you can regenerate with this way. For example, I can say replica set app1.yml. It is reproduced. You see this file, create wrote a dot, but the file you can reproduce like this. And another thing is you can reproduce a file, and another thing is you can directly add it in the etcd database. So for that reason, you will use kubectl edit. Kubectl edit will directly open your file in vim editor. So this kubectl command actually use some default editor. You can attach different editor. Maybe you can attach Notepad, or you can attach your Visual Studio, or whatever the editing tool you can use. But when you are installing this kubectl in Linux environment, the default editor is vim editor. So there is a when you will use this kubectl in Windows. So I think the default one is Notepad. So it will open in the Notepad. You will just modify your value and you can save it. It will apply directly save in the etcd database. So right now what I am going to change, just changing the number of replicas. So I want to change the replicas for example, I want to change to 14. I just save it, kubectl get pod. Now you can see all these pods 14. It is trying to create further 10 pods. So with this way, you can also edit. Okay, and if I show you in my CMD, I also have kubectl, and I believe yes, I have. So let me just check kubectl. Kubectl edit replica set. Front end. So let's see what, yeah, it is opening this notepad file. So in this notepad file, I will just change whatever I want to change. And for example, I want to change anything, whatever. Then I will just save and it will apply. You got the point? So all are in the running state. There is a command line way to scale up. kubectl, I believe there is scale. the scale. Yes, this is the way I can change. For example, I want to change replicas to back to 2, and replica set name is front end. Hyphen n I am not defining because you see it is in the default namespace. So it is scaled down. If I get the pods now, you can see all the pods are going in terminating state, only 2 left. So you got the idea with 3 ways I modified this directly in the etcd database. Now it will guarantee you these 2 running pods. So any question about this replica set? Are you good?
Basically, we can say that it's the auto-scaling sort of thing. The replica set is already known as auto.
No, no, it's not auto scaling. Auto scaling is a different thing. It's a manual scaling. And it will guarantee your pod health. Auto heal, it will your number of pods. It will guarantee you how many pods you need. But auto
When you
scaling is a different topic.
when you are defining the number of pods in your replica set file, then obviously you are telling you are configuring basically the number of pods, how much you need it.
Yes, it is not auto, it is manual. I did manually. But the system, you can also configure the auto scaler. We will do that. Will automatically sense you will define the percentage of CPU. This CPU load reach to this application, scale the pod to this level. It will automatically scale, and you will define the lower threshold value when the CPU load will reach to this percentage, automatically reduce the pod to minimum quantity. So here they gave the example, the horizontal pod autoscaler, minimum replicas will be 3, maximum it will go to 10. But this is an advanced level of topic, we will discuss this. So this is the replica set. So what benefit we got? We understand the auto healing, we understand the manual scaling, or auto scaling can also be configured, and how we can edit it. But there is a problem. For example, if I want to patch this, if I want to patch this replica set, and I want to modify this image from Nginx to HTTPD. Uh, Actually, in practical life, what will happen? This image contains your application, or I will not say HTTPD. I will say, for example, first your application was running in this pod, and its tag was something like V1. Okay. Now what you did, your developer did the changes in code, and you build a new image. You push the new image in the repository. And that new image contains the new piece of code. Okay. So that change now you want to apply in this replica set. So right now I don't have any example of the image that I have multiple tags variant. I'm not building the image on the real time. But in practical life, what you will see, you will build the image with the new tag, and then you will patch this replica set with the newer image variant. So for example, I am changing image from Nginx to HTTPD. Just think like you change the new version of image with the new version of application already hard coded in this image. Okay. Now I will do the save, and kubectl get pod. It will you it will, I think, just let me check again, is this change or not? Yeah, it is changed, but I think it will make some, it will take some time to. Oh no, this is not the feature of this replica set. You cannot do this. It is changed, but it will not update the image on the fly. Still, your pods are running. If I describe any pod, it is still running on Nginx. So this functionality that I want to get, this feature I want to get from ReplicaSet, this is beyond the level of ReplicaSet. So what you will do, I mean, the situation I gave you, that your developer wrote the new code, you build a new image based on that code, and now you want to deploy that code. So what you will do, kubectl get replica set, you will delete this. You will delete this replica set and this is deleted. Now what you will do, you will change in this image, in this manifest, the new image, whatever you pushed in your repository. Okay, this is another story, that if that repository is password protected and not your image is not public, so how you will provide the credentials? We will also see that. But right now we are gradually looking the stuff what you can do. So far we suppose that you push the image in your public repository, so it is publicly reachable by everyone. So now I will apply. I can also use create. Very first time when you are creating any resource, you don't need to use apply. So replica set value was 4 and get pods. It is trying to create the 4 pod on different worker node. Okay. I believe worker 2, okay, it will be in a while. So now all these new 4 pods are using the new image. So what you did, you simply delete your replica set and you update your manifest and you apply that new manifest. kubectl, just I quickly want to show you kubectl describe this pod, any pod. So you can see the time images HTTP. Now application is updated. Okay, but it's a downtime. It's a downtime. So replica set is not suitable in our professional life production environment to provide us a seamless migration or updation of running pods, replacement with the new image. So the solution of this problem is given by the Kubernetes resource, API resource deployment. So what is deployment? If we look into the documentation of the deployment, we can see the deployment provide declarative update of pod and replica set for pods and replica set. Mean deployment is taking the leverage of replica set, but it is adding the value of declaratively. Declarative mean whatever you can define in your manifest or on the fly. So it will update the new image. Your desired state of the deployment and the deployment controller change the actual state of the desired state of the controller rate. You can define the deployments to create a new replica set or to remove existing deployment and adopt all their resources with new deployment. Okay, so do not manage replica set owned by a deployment. Okay, actually, when we will use the deployment resource, it will create on the back end a replica set. So, but everything will be managed by the deployment. So that's why they wrote here that the replica set created by this deployment resource, whatever we will create, we don't need to modify directly that replica set. That will be managed by the deployment. So these are the use cases of the deployment. So create a deployment to roll out a replica set. Simple what we did. Replica set we roll out, we define the these number of replicas we need and those number of pod were defined. So this will be done by deployment. Declare a new state of the pod by updating the pod template specs. Mean whatever I try to edit directly in the manifest, it was failed in the replica set, but when I will do same with the with this deployment, it will directly talk with the replica set and will update the image variant, whatever I want to change. Rollback, I can roll back. For example, I update the variant of the new image in the application, and I found that the new code written by the developer has some serious bug or problems, but the previous variant was very good. I can roll back quickly. Okay, I can scale up just like I scale up and scale down by command line, by patching, or by editing directly in the database. I can scale up, scale down. Okay, pass the rollout. For example, you roll out some updates of your deployment and you are running 50 pods. So it will gradually shut down the old pod and update the new pod. And you notice that all the new pods are getting serious issue or is not healthy or the application is not good. So you can stop that rollout, whatever you have done. Or pass, I mean, whatever pods are updated, those will be, but rest of all will be stopped. Use the status of the deployment initiated a role has stuck. You can see when you will roll out the new image. So what is the status? How much percentage of pod are updated with the new image? And you can clean the whole replica set, I mean, older history of the images you can delete. So this is the manifest of deployment. The change is only you have to change the replica set with the deployment. Rest of all is everything is same, no difference. Okay, so and I think we can also create CTL create deployment hyphen help. You can also create this deployment resource by the command line. So no one is using replica set directly. Everyone is using deployment because the deployment is giving you the advanced level of feature. So you can create a deployment, very simple deployment, create deployment, the name of the deployment, whatever the image you want to use. So let me use this example, very simple example, and then I'm going to use my deployment. Okay, my deployment. And I want to use dry run, just like I showed you yesterday for the pod manifest I created. So you can use this syntax with any resource you can create by the command line and you can generate your own manifest. Dry run and what else I use -o YAML. This manifest is created. I will save this manifest. My deploy deployment.ym. I'm saving at same location, and my deployment.yml is created. By default, this replica value is 1. I can change this value with, for example, 6. This is the label, this is the name. I can add, for example, one more label. Example, uh, here it's backend. And container is, it is using busybox. I will use Nginx. It's the name of the container. It is the name of the image. So resources are unlimited. We will define here the CPU and RAM limit on this container. So far, we just want to understand the very basic manifest. Okay, so kubectl get replica set. I will delete. And this time I don't want to use in the default namespace, so I will use here namespace. I created a dev namespace. All the pods will go under this namespace. Or at the time of creation, if you define here, when I create this manifest, I can use here -n dev. It will write directly in the manifest namespace dev. So now I have this manifest, and kubectl apply you can type deployment. In the default namespace, there is nothing. In the dev namespace, we can see a deployment. 0 out of 6 are ready. So far, it's trying to create. And you can also write the short form deploy. And kubectl get pod, nothing, -n, dev namespace. So all are in the running state. If I again query the deploy, you can see 6 out of 6 are in ready state. And the behavior of assigning the name is quite different than ReplicaSet. And another thing you must have to notice, the ReplicaSet is also created by this deployment. So we don't need to take care directly. We will interact only with our deployment. So the same thing I can do. I can do kubectl scale deploy. The deployment name is my dep. I think replicas is equal to, for example, I want to set to 10, and in the dev namespace, it's scaled. So get pods, you can see it is scale up. By the command line, I scale up. And what else I can use? I can directly edit in the manifest file, or I can directly use the edit you edit to edit this deployment. It will open the manifest real time. You can change this to the 120 replicas. Okay, and you can see the get pods. So all the new pods are creation under process. Okay. Okay, so now I have 20 these pods running under this deployment. And if I look into the replica set managed by this deployment, is giving also me the situation, but I must have to query the deployment only. I will not query the replica set. So 20 out of 20 are up and running. Now let me just do an edit to this deployment, and let me change this image with the new variant. So in your practical life, actually, it will be done by the change of tag of the image. So here I am just changing the image with HTTPD, and name engine is no problem. The application, it doesn't matter, but this is the image I change. You can see 15 out of 20 up. And if I do a get pod, so pods, older pods are terminating and the newer pods are creating. So it is deleting gradually the old pods and replacing the new pods with the new image, whatever you provided. But this was not doable in your replica set. So kubectl, if I describe this pod that is running 22 seconds ago in dev namespace, so this description is showing me its image is updated to HTTPD. Okay. So how this gradual upgradation happen? Uh, Actually, if I show you this manifest, so in this manifest, here it is not written. Yeah, here it is written strategy. And just where I told you that wherever in cluster manifest resource, you see these brackets mean the default value is used. Just like you can see this for the resources, default value is unlimited. Similarly, strategy, a default value is used. And what is the default strategy? And if you want to understand a default strategy, you can do uh, you can do uh, for example, edit. I just want to see what actually strategy is defined inside my etcd database, because the default value will be supplied here. So if I go here, you can see the strategy, the rolling update, max search 25 and max unavailable 25. So this is a percentage. When you will do a role update, so it will shut down your 25% of pods and will update the 25% pod. Then next 25%, and then so what happened? I had 20 pods, so it tried to shut down first five and then update the first five, then next five. So it depends. You can change this value. And max unavailable. For example, due to this rolling update, some pods are failed to start. So it will make sure at least uh, 25 percent of pods are unavailable. If you have 4 pods in this deployment, so 25 mean at least one. So at least one will remain up and running with the older variant, because cluster knows that the new pods are making issue. So this strategy is depends on your requirement. If you have mm, large number of pods running under this deployment, you will change this value according to your requirement. Okay, so this
Yes,
way, yes, yes, sir.
yeah, I have. If we deploy the latest version, for example, and we have 10 pods, 9 pods, we knows that this is has been corrupted, or and one will be retained as an older. So how, as perspective with the end user, we so the world will, for example, this application is publicly accessible. So which version basically they will the one that is working fine, they will use this one, or what is this? Uh,
No, it will be gradual. It will be gradual, mean you have these 20 pods and you roll an update. So, for example, your 10 pods are on the new version of image, 10 are running on the old version. This is the middle stage. Or 15 are with the new, or 5 with the older version. So there will be a load balancer on top of these pods, and that load balancer is sending a round robin traffic to these pods that is coming from the customer side. So whatever traffic is routed to the new pod, customer will see the new application. Whatever traffic will go to the old pod, customer will see the old application. So, and the session, for example, a user is connected with the pod and he's doing his job. And that pod is deleted due to rolling update. The customer will lose the application session. And when he will do the refresh, he need to do the news, create the new session.
Okay, so it means sometime we have publicly application, and that is basically accessible from some feature, new feature, developer basically build a new feature, and unfortunately this new feature is bug on the you we can say in the new pods. So on that case, if this application is the live, so sometimes users getting the older application, and sometimes user the getting new bug one application. Is it right? This
Yes, it will happen, but actually when your application will go in the production, it will not go blindly. We are talking about this strategy for the dev environment, for the developers. Developer wrote a code, developer pushed the image, and then roll out the update, the roll out the deployment, and the developer get the new application. It is good for the developer perspective. Then your application will go to the QA team. The QA team will verify your application for vulnerabilities, for bugs, for application functionality, everything. It will take days for the QA team to verify the new functionality. And then this application will go to some other environment, security testing. Then it will go to UAT, user acceptance testing. Then it will go in the production. So when this application will go in the production, it is 100% guaranteed that this application does not contain any bug, first thing. But this is still human error are still there. Still there are chances the core application, because you know your application real tester is your end user. So uh, in that case, this rolling update you will do in the time when there are less number of users. But there are applications that are 24/7 up and running. There is no chance to make a less number of applications. Then there is a concept of blue-green deployment, or you can take the planned downtime, just like sometime you saw on different Facebook or Twitter, whatever. Sometime they are giving message that this application, this site is not reachable for seconds. So at that time, basically, they are doing the rolling update. And data loss will not happen, only session will loss. But this will this will be a planned downtime, or you there is a concept of blue-green deployment. Blue-green deployment we will discuss later, that parallel another deployment is running and you can route your traffic to that deployment.
got it. Excellent. Thank you.
So now we understand how we can do the rollout, but we have to understand the true sense of the deployment. So far what we did, declare a new state of the pod. We did this. So now if I go down, mm, you can do scale up by editing, or you can scale up, scale down by directly in the manifest, apply the new manifest, or you can do by the command line, whatever I showed you. Okay, the another thing that you have to take care, updating the deployment. Okay, so updating the deployment in your professional life is not like you will edit in the manifest file and then you will reapply. This is good when you are managing directly by the command line, but things are automated in the DevOps. And automated things will use some script. Script, you cannot write a script that will edit your file and it will update. So that will be by the command line, and this is the command. And this is the command that kubectl set image to the new image name to your deployment. So let me do this now. How can I do, for example, first of all, I should know what container, for example, this pod contain multiple containers. This pod running right now, I have only one pod, but maybe in production you have multiple containers running inside this pod. First of all, I should know what is the name of the container running in this pod, in these pods. You can also do the describe, not, you don't need to describe directly pod. You do the description of your deployment. So if you do this, you can see the image is also mentioned here, label is mentioned here. And yeah, in the description, it is also mentioned rolling update strategy. Everything is mentioned here. And here the image is also defined. Okay, it's based on image. I have not defined any port, host port, environment variable. I have not mounted anything, volume, nothing. We will do this. But so far, I know the container name is Nginx, and it is using this image, whatever the image is. Okay, so now I want to update. So I should know this container I want to update in this deployment. So kubectl set image, and then the deployment or deploy, you can write here. And then deployment name is my dep, and what container you want to update with the new image. So I have this container name is Nginx, and I want to change this with Tomcat. Okay, in the namespace def. So image updated. If I do get pods, you will see all the old pod are terminating, creating new pod. Why I'm using these images? Because these images are already available on my worker nodes. It will not take too much time. And you can also see the status. Actually, it is happening very quickly. So you can do edit, and yeah, this is the command. Uh, this is the command you have to use. Actually, in production, it will not be quickly, because the application image pull could take time, and the new container startup can take time. Here we are using very simple images. Sorry. hyphen and have namespace. So it will give me the status, how much rollout is done. So you can see waiting for the deployment, my deployment rollout to finish 13 out of 20. New replica set is updated. So it will show you in the runtime how much update is done so far. Okay, and get deployment you can do, get replica set you can do, get pods you can do. Then it is explaining you the deployment strategy. And you will read all the stuff, you will get the new idea. I cannot explain everything. And yeah, and there is a rollback. And there is a rollback, a deployment. So rolling back a deployment, uh, you set some new image. Okay, it is updated. Rollout status, you see, it is showing you the rollout status. You can do a control C when this is happening. I think no, this is the status. You cannot do control C. So get pods. Pods are up, and here the error happen. The new image you provided is not available on the repository. Mistakenly, you provide the wrong image. What they use this one. They did a typo mistake. Actually, image name was this, but you mentioned this was the actual image name, but you mentioned mistakenly this one. But your rollout will not happen. So max unavailable this time will save your life, because it by default 25% can be unavailable, I think. Okay, so now rollout history. So for example, let me check this 13 out of. It is still trying to create, because I believe two worker nodes don't have these image, and this image size is, I believe, more than 500 MB. That's why it's taking time. Okay, so what next I can show you the rollout history. Okay, and so rollout history is a command that will show you whatever you have done so far. So you can see 15 out of 20 are updated. Real time it is updating. 15 of 20 updated replica are unavailable. So it will be on the back end. I don't want to. So it is creating on the back end. So now kubectl history, rollout history, deployment. I think my dp-ndef. So 3 rollout we have done. One I directly added with the I directly added inside the file. Second one I did with the no, first one, whatever for the starting point in the manifest. Second, I change Nginx to HTTPD. Third one, HTTPD to Tomcat I change. Okay, so but you don't know what happened actually here. So whenever you will do a rolling update, let me just check the status. It is successfully rolled out. So for example, I set the image. I just set the image back to Nginx. I'm not happy with this new version. Okay, so I will use hyphen record in parallel to this rollout. Okay, has been deprecated, will be removed in the future. Okay, so now when I will see this history, you can see the fourth last one what I did is also recorded here. So now you know what happened in the fourth rollout. It is by default showing only 3. I don't know. There is some another command that will show me all the history. It is not showing me the number 1 now. Or I think by default it is showing only 3, or it is preserving only 3. I don't know exactly. So right now, what I did, I switched to this revision 4. Okay. Now I want to go back to revision 3. So this command will help you. So roll out history. Roll out history deployment hyphen revision to revision 3 or revision 2. I want to go to this level in dev namespace. Okay, and it showed me in that revision image was HTTPD. Now let me quickly see the status. It is quickly done because all the images kubectl get pod -n dev. You can see just is updating. Everything is done quickly. Any pod, if you pick kubectl, describe pod. So image, I can see it's is Nginx. No, it should be. Yes, it is still creating. You can see time is changing. So in that region, I don't know exactly what was the variant. It showed me it was HTTPD. Actually, that message was showing me it is HTTPD to Nginx. It is shifted. So all the images are updated. So now you can see you can switch to any revision. If something happened wrong, you can quickly roll back. You don't need to remember the older image variant use. It will save in its database. Okay. And sometime you don't want to jump to, if you want to jump to the very old revision, you can use this method. Otherwise, you can use this method. The very last one used image will automatically be roll out. kubectl rollout undo. I mean, whatever rollout you have done, it will do the undo. Right now it's using Nginx. It will revert back to, I think, Tomcat I used. Undo, deploy. Right.
If I run the revision 4 and 5, I want to check the date and time. So how can I check? Let's say a revision 4 I have done in December. So and I want to check the deployment which was in the stable version in December. That may be revision 4 or 5. So how can I get this?
I don't know exactly what is the way. Actually, we don't need to go back to this much of older variant. I think this is only to roll back the very nearest variant you roll out. But when you are going to roll back your application to very old variant, last year that feature was very good. So actually that is managed by the variant control system in the Git. So if from the Git there will be a branch that contain all the code, you can rebuild the image and you can redeploy it. So these types of big decisions are not taken by this rolling out technology, because you are going to roll back your application to very older variant. So this is a big decision. But this rolling update is only helping you very nearby changes you have done.
Valid. Absolutely valid. Valid. Thank you.
You're welcome. So you got the idea how this rolling update is working and scaling up and scaling down, and how deployment is quite different. I mean, beneficial as compared to ReplicaSet. Okay, I'm just going to take a look on, yeah, set image we have done. Did anything left behind?
Nowadays, people are using the deployment rather than the replication set, right?
No, replication set no one is using.
Okay.
Actually, replication set is controlled by deployment.
Mhm.
Replication set is actually providing you the auto healing. Whenever your pod will delete, it will automatically be granted by the controller manager.
Got it.
Okay, so this was the whole story. You just need to focus on these points uh, about the deployment, the use cases. Someone asks you what are the use cases, why you are using deployment, so you should know all these. Uh, this is the answer of everything. So far, what we did the simple pod deployment, we did replica set, we did deployment. Now we have to take a look to another resource. Uh, so deployment we have done, replica set we deployment done. Now we have to look into DaemonSet and stateful set. Okay, so we are going to take just 2-3 minutes break, and then we will resume. Okay, we are resuming now. Any questions so far? And you can see my screen. I think we lost this session.
Screen sharing is stop.
Okay, so now we have to look into the DaemonSet.
I have one question before that.
Yes, please.
Yes, you you explained that we have to use the sorry, this job usually done by the developers, right? To create the to build the script to run the some programs and then update it accordingly. So this will all the things to ports create and done by the developers, or someone administrator will do this job.
Depends. In big organization, I saw that developer are writing the manifest, and they have their user limited user access to the Kubernetes cluster, and they are just deploying directly by the kubectl command.
Mhm.
But in big organization, I also saw they just gave the duty to the developer to only write the code and just commit the code in the Git, nothing else. Whenever any change will happen in the Git, a specific repository and a specific branch, that will automatically be sensed by the automation tool, just like Jenkins. And Jenkins will pull the new code and will build the artifactory and then will build the new image based on that new artifactory, will push the image to the repository and will also roll out this deployment to your Kubernetes cluster. So it depends. Sometime the developer has access. I mean, they don't want to use the pipelining method, and they will give this kubectl utility on the developer laptop. They will ask the developer to just roll out whatever you have pushed in the repository with the set image command.
Got it.
Basically, it's not responsibility of DevOps to uh, deploy code.
No, this is a deployment of a, code is the responsibility of a DevOps engineer. Whatever is written by the developer, you actually DevOps engineer is very closely working with the developers. A DevOps engineer should know what programming languages are, how to build it, just like Node or Angular or Java. So what tools they are using to build the artifactory and what are the dependencies. Actually, whenever you are building, all the dependencies are automatically resolved. We will perform some real-time application deployment after the completion of this Kubernetes course. So I will show you the examples of some real-time application, Node.js, Java, Angular, PHP, HTML, C, C++, or Python, whatever is in use. So then you will get the idea how this whole cycle is working.
So it means we also need to learn something about the speed as well.
Sorry?
Means we need to know about the tools as well, like Java, Node.js, and languages,
Yes,
whatever.
you should know. because you have to do a lot of troubleshooting too. So in that case, you should know how this building process is working. Not exactly the code, but the building process. Okay, so now we are going to the DaemonSet. What is DaemonSet? DaemonSet ensures that all or some nodes run a copy of the pod. As nodes are added to the cluster pod are added to them. So DaemonSet simply ensures that whatever image you define in your manifest of DaemonSet, it will build the pod based on those images. I will make sure a single copy of pod on all nodes. So the use case of this daemon set is, for example, you want to use some monitoring tool, or you want to use some log collector tool, or there can be any other automation tool that should any service that you want to run on all nodes. In that case, it will run a single pod on each node. Okay. So some typical use cases are running a cluster storage daemon, running a log collection, monitoring, and a lot of other could be. So let me show you how DaemonSet already we deployed. If I do a kubectl get DaemonSet -n kube system namespace. So actually we already ran two DaemonSet. The kube proxy automatically roll out when we use this kube Adam init. So kube proxy DaemonSet automatically started, and you can see we have 4 worker node, 3 worker node, 1 master node. Kube proxy is running on each node. Similarly, Calico would you use. So this is actually an example of DaemonSet. So let me write my own DaemonSet, and the difference in you can also use the kubectl create. I think hyphen help. I showed you DaemonSet we cannot create. DaemonSet we cannot create. Okay, no problem. Actually, if you know how to create the manifest of deployment, just for example, I want to copy my DaemonSet. So my DaemonSet. So here, what I should change here is follow the documentation. You don't need to worry about the syntax. T caps and SS caps. And replica set is not required. Okay, I deleted replica set. And strategy is not required. And this status is not required. So why I remove the replica set? Because it will automatically span across the cluster 1 pod on each node. So this is just the change in between deployment and a replica set. And here I am using, okay, I'm using Nginx, but Nginx is not a proper main example to run as a daemon set. There will be some image of monitoring system or some log collector. We will do those projects later on, but right now we are just getting the understanding. So let me, and I will change this all the deployment with my daemon set, and tier is, for example, monitoring. Okay, it's a daemon set namespace. Namespace, yeah, it can be under the namespace, and I will set up under the namespace monitoring.
TS means what was the TS?
Where is DS is daemon set.
No, tier.
Short form.
Tier.
Where is TS? Tier is just a label. No, this is just a label. You can set here the label like this. Let me show you. For example, name Yasser. It depends.
Oh,
Whatever, this is not a hard and fast rule. This is just your representation, key and value, any key, any value.
okay, okay.
This is label, just like you put a sticky note on your desk, whatever you can write on the sticky note. So this is just a sticky note. You can say that is a representation to identify the Kubernetes resource. So now, okay, one more thing. kubectl get deploy -n dev namespace. Okay, deploy. Yeah, here you can also use -fn show labels. So it will show you whatever labels you associated with your with your resource. Okay. This is very helpful. I will also give you an example. For example, I want to delete, for example, kubectl, delete, delete all, everything I want to delete. Okay, from dev namespace. It will delete everything, but I want to delete only the objects. For example, there can be a lot of resources in a namespace. So I only want to delete a resource that label is like this. So all the resources will not have the label like this. So far, I have only one resource, but this will help you to, and without identifying, I mean, maybe multiple resources are using same label. So in that case, all the resources will automatically be removed. So this is one use of the label. So you can see this by using the library. There are a lot of other benefits we will see gradually of labeling. Okay, now we have to deploy our daemon set. Let me just clean up this one. Daemon set we modified already. The manifest. I'm doing a control C on the background. It will be deleting. While I created. So this was good. Okay. kubectl apply. It will give me an error. Why? The namespace I defined is not created yet. So kubectl so you can see my daemon set a desire for and okay, how this is running 4 out of 4. Get pod -o wide. So on each node it is running a pod. If I add a new worker node, it will automatically launch the new. It will automatically launch the new pod on that specific node. Okay, and one thing I want to check. Okay, kubectl get nodes describe node. First of all, get nodes, and I can use a describe node too. It is very helpful whenever you want to see what is happening in what node. So it will give you a very detailed information. I mean, name, the role, labels assigned, annotation. This is the taint. We will discuss this. Actually, this is very strange why this master node is not tainted. This is another topic, but actually this taint is blocking the deployment of workload, application workload on master node. So this is strange why the taint is not defined, but no problem. uh, and you can see the messages, the IP. Yes, this is very important. How much capacity it has, CPU, RAM, allocated, and max number of pods it can hold, this number, and how much percentage or CPU is used. It will also be mentioned here. Yes, this is also showing that what pods are running under what namespace on this node, and how much CPU and RAM and memory is consumed by those pods. And this much of CPU, 45% CPU is consumed, and 2% of RAM is consumed so far on this node. So VU worker 1, if I look, so you can see the taint is also not defined on this one. And these yeah, these pods are running on this worker node, whatever the load, whatever the CPU RAM has is left. So by using these footprints, the scheduler is deciding where to load has to distribute.
But what is the actually benefit? I do not understand what deployment and the DaemonSet. Deployment has all the same has the same things, and when we create the manifest for the DaemonSet, so what is
No,
the
there is a big difference. You have not defined the replica set in the deployment, the daemon. In the deployment, this was my deployment. I defined the replicas. I defined the rollout strategy. But in parallel to my daemon set, I have not defined anything like this. I have not defined the replica set. I have not defined the strategy.
okay?
So
Means
I asked the API to just roll out a pod using this image on each node simply. So we have kubectl get nodes. We have 4 nodes. So we are kubectl get DaemonSet in monitoring 4, because we have 4 nodes. And if
okay.
I do a pod get pod, we have 4 pod and hyphen o white, worker 3, worker 1, master 1, worker 2. Each has a pod, whatever I defined.
So let me revise my question. So basically, first, for example, I am the developer. Now I have four methods. I can deploy my application or manifest. One is the deployment. Second one is the replica set. Third is a demonstrator. Fourth is a stateful set. Right? This is four different ways, and doing the same. Someone has the feature that only run the daemon and low resources. This is mean like or something else. Uh,
No, I'm
what?
not getting your point. I mean, you have, I mean, your question is how you will decide what type of API resource you need to use to deploy your application, either daemon set or either replica set or
Uh,
deployment.
yeah, yeah, yeah.
No, simple question. Simple is you will, if this is an application, if this is an application, you definitely want to use that application with the auto scaling. You want to scale up, scale down. You cannot up, scale down the replica set. You
Okay.
can scale up, scale down the deployment and no, sorry, daemon set. You cannot scale up, scale down the replica daemon set, but you can scale up, scale down deployment and replica set. So you can deploy your application only in replica set or deployment. Now, the limitation of replica set is its rollout.
Patch update. Yeah.
So then you will only use the deployment for your application. So your application will not run in the form of this daemon set, because these applications are only for the cluster administration related task.
Got it.
Okay.
So got it. So one application can be the deployment and the daemon set as well. One application, or should I?
Yes, yes. I mean, you use the same image for both. Doesn't matter.
Okay. Okay.
Okay. So, but the actual production application will always stateless application. Stateless application will always go in the deployment or replica set. And I gave you the example. So you need a virtual switch on each node. So that's why kubectl get daemonset -n system. We saw there are two daemonset automatically used by the Calico. Calico doesn't use the deployment, because deployment will not guarantee you each pod on each node. Maybe deployment will roll out these 4 pods, but 2 on one worker node, 2 on second worker node. Then how you can roll out a virtual switch on each node? So in that case, the daemon set is came into the picture. And then kubeproxy. Kubeproxy responsibility is to write the IP table rules to make the application accessibility outside the cluster. We will do this, but at the time of setting up this cluster, this kubeproxy daemon set automatically roll out. So each worker node and master node has a kubeproxy engine running. So later on, we will do the monitoring by Prometheus and Grafana. So you will see we will use this demo set to set up the monitoring. And then we have to use the Elastic ELK, uh, Elastic logging system by using Kibana or stuff like this. So we will use this daemon set.
Okay. The first line when you write running a cluster storage daemon on every node. What does this mean? Running a cluster storage daemon on every node.
Cluster storage daemon, here it is written. This is
Yeah.
the example main, this
Yeah.
one.
Yeah. This one. Yes. Yes.
Yeah. So in real life, you want to in the cloud. Actually, we have not covered this topic so far, the storage class. So
Okay.
you have to attach the storage for the pod for the as a volume. Okay. So that daemon will take care the volumes you purchase from the cloud, just like you purchase a block storage device. Okay. So that daemon will take care that block storage device is attached with that worker node that is working as a volume. So that daemon is actually a system, a service running on all the nodes that are taking care of all the relevant storage is attached with the worker node. Right now, we have not, we have deployed simple the stateless application. When we will deploy the stateful application, you will see that what is happening.
Got it.
Okay.
Got
So this was the DaemonSet. Okay. Now,
Sorry,
yes.
last QB proxy and Calico node both are the stateless, right?
Yes, both are stateless.
Okay, got it.
Think like you have a switch, Cisco switch. So you will, what you will do in the Cisco switch, you will configure DHCP or VLAN or inter VLAN routing, whatever you want to configure. Okay, you configure it, you commit what command you are using in Cisco switch.
Copy, write, write
Yeah, write memory to the flash. So you will do this, and everything is now inside that switch. If that switch is going up and down, everything is inside that switch. So switch is an example of a stateless application. One time you build it, it is running. So wherever that switch will go, it will have the functionality. Same thing is going with these Calico virtual switches running in the form of pod. So everything is built, is hard coded into the image of those pods. When we deploy, we define the when it will deploy, it will define the IP range. The cluster will automatically define the IP range. So everything is hard coded. So it's an example of a stateless application. So mean the simple definition, stateless application, all the configuration files and everything, when you build the image, you use the copy instruction and copy those configuration file into the image at the time of the building the image. And when the image will run, well, you will use those configuration file is those configuration files that state only. You are mounting a volume and you are changing the configuration by using the volume that is reflecting inside the image, that is getting a stateless application. Oh, sorry, stateful application.
Stateful.
Yeah. Okay. So next resource that we are going to look that is a stateful set. STS. It's a stateful set. So stateful set, let me. A stateful set is a workload API object used to manage stateful applications. ReplicaSet, deployment, DaemonSet, all are used to manage stateless application. But stateful set is used to manage the stateful application. Okay. So actually, I am not going to do this practically today because you will not understand this concept unless we are not going to have a walkthrough with the volume management concept of the Kubernetes.
Yes.
Okay. Manage the deployment and scaling of the pod and provide guarantee about the ordering or the uniqueness of the pod. It will work same like the deployment. Mean you can scale up, you can scale down. Scheduler will automatically distribute the load across the cluster on different worker nodes. The same behavior. Okay. I think you can do the rolling updates too, but using stateful set variable for more scale, unique network identifier, scale, and persistent storage. Yes, order automated role update. It will support, but the difference is it will create the pod name right now. If you notice, the pod name created by this was randomly PHX, because we are not concerning with the name of the pod. Okay. But when you are using the stateful set, the pod name is very important. Why? Uh, in that, I think we should not discuss this today because this will be confusing. First of all, I will cover the volume, and then we will see how this stateful set in a database is running under this stateful set, and what is the benefit of running database under stateful set.
Yes, daemon deployment replica set is also very vast. So yes, we will first go through this one, then we will go for the stateful. You're
Yes.
absolutely right. Yes. Yeah.
So you can see this is talking about the volume claim. So this whole story is revolving around the stateful applications, and the databases are always go under the stateful set. It is managing the pod identity. It will give a special name to each pod. The name will be same like, and then -0, -1, -2, something like this. Maybe they will, yeah, something like this, web 0, web 1, web 2, web 3. So you can directly identify the pod. Right now in the stateless application, we are not concerned what is the name. But in stateful, we are very concerned. And what is the reason of that concerning? We need to understand another concept of networking, the servicing. What services we can use as a load balancer on in front of this replica set or daemon set or stateful set and deployment to distribute the traffic across these all pods we set up. Okay, so just a minute, I want to. Rolling update is a feature, same like deployment. Okay, so the last topic that we have covered today, I think it's late, or we can do one more thing if you are good. The one thing that will not take more than 10 minutes. The
Sure. You can.
the concept of static pod.
The concept of static pod.
Okay.
For example, I have okay, can you hear me?
Yes. Yes, we can hear you.
Okay, so actually I switched to speaker. Okay, so the static pods, how static pods are working. Every worker node and every master node has a directory etc Kubernetes manifest, and it contains the manifest of whatever the pods are running in a form of static pod. Okay, so we can see etcd API controller manager kube scheduler. Okay, let me go to another worker node. etc Kubernetes manifest. It does not contain anything. It does not contain anything, but the master node contain some manifest. Actually, kubectl get pods -n kube system. You can see, maybe you noticed this pod name is ending with the name of the node where it is running. You noticed? Let me show you. This pod is running on master node. But this pod is also having a name at the end like the name of the master node. Okay, this pod is running on master node,
But this pod is also having the name. Okay, this pod has the name, and what else? This etcd has the name. So the biggest identification of a static pod is its name is ending with the name of the node that is responsible to run it. Okay, now let me just copy. I created this app one. You remember? I created this manifest yesterday. I'm just copying this file here. Let me see what is this. This is a simple pod. Its name is app1 and it's running under dev namespace using Nginx image. Okay, so let me now so you can see this pod automatically started with the name as a static pod with the name of the node that is responsible to run it. So I bypass the API, I bypass the scheduler, okay, and I ask directly cluster to run this pod on this node. Let me let me copy, for example, I have this app3, okay, so this app3, okay, let me just quickly SCP this file to 192.168.590. For example, worker node 2, 103 is the worker node 2, and I want to copy under the temp. Sorry, it will not work like this. So under the worker node 3, under the temp, I had copy this manifest. So let me move this file, okay, to etc Kubernetes manifest directory. Oh, sorry, permission denied. It must be a root. Now I will go back. I will see kubectl get pod a. So you can see the worker node. This pod is running on worker node 2. -o white. So I have not did kubectl apply. I just put that manifest file in that worker node, and that worker node quickly take the ownership of that pod and directly ask the kubelet to run this pod. Simply. You got the point? So these are the static pods. And what is the benefit of static pods? All my master node control plane services, the API, the etcd, the scheduler, and the controller manager are running as a static pod. Okay, and if I want to stop any of this etcd or any service, I simply need to remove this file from here. It will be stopped. I'm just deleting this file. You will see this pod is gone now. The first one is gone. This one.
Just I need to delete this file or remove this file. It is gone quickly. So we bypass the scheduler, everything. So this is a concept of the static pod. So if you go to this static pod, create a static pod. Static pod and managed directly by the kubelet daemon. Okay, so let me show you the diagram we had. So actually, we directly instructed to this kubelet when we put this file in that directly, we directly instructed the kubelet. So far as an admin, we use the kubectl command to API and then API requested the kubelet. But now, if you look this definition, static pod managed directly by the kubelet daemon on a specific node without the API server observing them, unlike pod that are managed by the control plane. For example, the deployment instead of kubelet watches each static pod. Static pod are always bound to one kubelet on a specific node. Simple. Okay, so just take a look on this documentation. And here they just created this a static pod. You will get the idea how static pod is working. Okay, so we are done for today. Any question about this concept static pod or whatever we learn, you can ask. And the other thing is, in the next session, what is our target? We have to understand the concept of services. What is a service in the Kubernetes? And how many services we have? And next, second thing is we have to understand the persistent volume and persistent volume claim. These three concepts we have to, yeah, this is also coming under the persistent volume and persistent volume claim. So this will be the topic of our next session. Okay, now any question?
Can you share this stuff by maybe diagram or having your
Yeah, I will put in the Git repo. Anything else?
Thank you, Asim. Thank you. Jazakallah khair.
Okay. Okay.
Thank you so much. Thank you.
Thank you, Asim. Jazakallah.